Welcome once again to discussing symbols and components that make up wiring diagrams and how to understand them. Much confusion about these things. Let's take, for example, the first one, mass airflow sensor. Mass airflow sensor monitors how much air is going into the intake system. So, some vehicles have mass airflow sensor in itself. Some have something called intake air temperature, which monitors the temperature of the air. Is it cold? Is it hot? In one unit. So therefore, you see this diagram? One sensor and another sensor is contained in one unit. Like the Fords and all that. They have, if you see 5 wires, that means it has 2 sensors in it. If you see 3 wires, that means it has a mass airflow sensor in it. Now, which is which? To tell from these things, ground is ground. You always need a voltage source, whether it's 12 volts or 5 volts. It has to have an ignition. Ignition means there's a voltage, like a B+. Now, who gives this B+? The computer. So, the computer is giving us the 5 volts in this case, and the ground over here, which is physical, not the computerized. And a signal has to go back, as you see the arrow pointing. This is coming in, 5 volts, and it's going out, going a feedback to the computer. Now, if you have 5 volts at the most, how much can a mass airflow signal be? It can only be up to 5 volts. Obviously, it's going to be less and less and less, dependent upon how much air or how much you open the throttle and how much air is being delivered in to the intake manifold, to the engine. So therefore, we have to start at 5 volts. Can we go 6 volts? No. We cannot go more than this reference. What about this one? This is also a resistor, coolant temperature resistor, intake air. All these are a resistor that changes value. Where do you think this one goes to, where I put the arrow going out? The computer. The computer has to give 5 volts, the tan line, you see this going in, and it has to go out giving the information of the temperature of the air. So the computer giveth, and the computer taketh, like they say, right? Doesn't matter what type of sensor. Let's do different ones. As you see over here, they're just specified. Here's a 5 volt reference. Which is the wire, the connector that's going to change? The middle one right here. As you open up the throttle for more gas, this either goes up to 5 volts, gets closer to 5 volts, or it gets closer to reference low, which is ground, 0 volts. So it can go from 5 volts to 0 volts. It could go 2 volts, 3 volts, 1 volt. Can't go 6 volts or 7 volts or 8 volts. Why? Because the most that the computer gives you is 5 volts. That's what we call this the reference. You can never go more than the reference. You can only go below it. Which signal goes back to the computer? This is a signal that goes back. So it could go from 5 volts, 0 volts, go 2.5 volts, 3 volts. And remember, for computers, you talk about hundredth of a volt. It could be 0.01 volt. It could be 0.02, 0.03, 0.04. Precise. How about this one? 2. Yellow and the black. How much can the computer give? The computer will give you 5 volts. And there's a low over here. So it'll give you the 5 volts because it needs 5 volts, but also it'll be based on that reference. It's going to give a feedback how much this voltage goes down. So this voltage can go down to 3 volts, 2 volts, 1 volt, whatever. Cannot go past 6 volts, 8 volts, 9 volts. Why? This is the reference. Can't go more than the supply that the computer is giving it. What about a motor? Here are the symbols for a motor. How much can this be? It could be 12 volts. Going to one side, the other side is obviously grounded. Let's take more examples. Okay? Now, engine coolant level switch. Level of the coolant in some vehicles. In this position, at rest position that we call it, when it's not activated, engaged, it's in an open position. There is no connection from this light green wire to the black wire. Nothing. When it is engaged, when it is closed, as we say, when it is closed, let's close it. This is pivoted or toggled from here to here. Now, do we have a connection from here to here? Yes, light green wire is connected through the switch to the black wire to ground. Where do you think this goes to? If this gives information, the coolant level, where do you think this other side would go to? If you said the computer, you're correct. What other component besides the computer will need to know this information? Only the computer. Okay, same thing. Engine oil level switch. If the level of your oil has decreased dramatically, what do you think will happen? This will close. When this closes, it gets a ground to the computer. The computer says there's a problem with the engine oil level. Okay, stop lamp switch. Is the brown connected to the purple? At this moment, no. What do we need? We have to go on the brake. And then we have a connection from the brown to the purple. Okay, let's do some more. Again, mass airflow sensor. How many connectors are there? How many connections are there? 1, 2, 3, 4, 5. So remember I just pointed out to you that a mass airflow sensor has 3. Why do we have 5? Look at this. Like we just mentioned, intake air temperature sensor is part of the unit also. Instead of 3, we will have 5. Which is the signal wire? Is it the pink, the yellow, the tan? If you said the yellow, you're correct. Which is going to go back to the computer, giving feedback to the computer. Notice I deliberately left all these things out. I didn't draw anything so that you can use knowledge and figure these things out. So in other words, which one is the signal wire going back, giving the computer feedback, how much air is coming in? If you said the yellow one, you are correct. This is an output. Where is it an input? The pink one is an input. Why? Because this is ignition. It needs 5 volts. Where is the ground wire? What color? Black and white striped. Over here. What are the 2 other wires for the intake air temperature sensor? And what is the intake air temperature we just discussed? It's going to have 2 wires. It's going to have a tan. It's going to have a black. Where is this feedback or information going to go to? If you said the computer, you're correct. Okay? Vehicle speed sensor. How many wires? 2. Dictates the speed of the vehicle. 20 miles an hour, 30 miles an hour. Where do you think this information is going to go to? If you said the computer, you're correct. You see, these are not connected. And I just want you to figure out where do you think it's connected to. Let's do some more. Let's continue. Kind of a tricky one right now. We talked about this one before. In which position is the orange wire going to be connected to the white wire? In the park, in the order, or in the headlamp position? If you said the headlamp position, you're correct. That's the only one that has a connector here, a wire here, and a wire here. Let's do this one. It's a little tricky. Let's put in 12 volts from the battery. Let's put in a ground over here. Current flows, whatever there is. It could be a relay. There could be a computer here. Could be fuses here. Not important. How many? 1, 2, 3, 4. Okay? These are the switches. Left power window switch. Left power door lock switch. For the window. This is for the window. This is for the heated seat switch. These are illuminated. These are the bulbs that come on when you activate something. So, let's say all these bulbs are not lit. All of these. First, in order to troubleshoot, we have to know first how current flows. Current flows from here, regardless of conventional, regardless of electron flow, doesn't make a difference. These bulbs don't care which direction the current is flowing, here or here, it doesn't care. So let's start. Usually I start from 12 volts. The current divides. This is a node, I call it. They call it a splice. Current comes here, and this is the ground. Fine. So let's. L1 is taken care of. It's lit. L2 and L3 and L4. How are we going to get L2 lit? With the left power window switch. Right? We're going to press on the window switch to activate it. So current now flows here. It has another path to go here to light it. Now the problem is, where's the current going to flow? Is it going to flow back here? No. Is it going to flow back up here? No. Is it going to flow back up here to ground? Yes. Why? Why will the current go here and why will the current not go back up here? Because this is ground. Current always takes the path of least amount of resistance. How much more least amount of resistance can you have than going directly to ground? This is 0 ohms. This is more than 0 ohms. So this will go here. Current will go here. As you see the arrow, go out here, come out here, and go back to ground. That's great. So we lit this one, we lit this one. What about these? How is this going to be lit? Current comes to this point, or the splice, or the node, comes over here and says, okay, I'm going to go through this brown wire. I'm going to light him up when he activates the switch. The black, and now I'm going to come out here. Where is he going to go again? We just said a rule. You take the least amount of resistance. Where is the least amount of resistance? Right here. Back over here. This is the ground. He's not going to go back up here. If it goes over here, it's going to go through this one or this one. No, you don't do that. Here, goes over here, follow the arrow, in the brown, out the black, here, and out this black. What about this one? What about L4? He's lit, he's lit, he's lit, no problem. Come over here, come over here, come over here. Goes in the brown one, comes out the black one. Now where do we go? Black here? Nope. Same rule applies. Where's ground? Ground is here. Current flows now back up here. So they all end up going, boom, this way. This way, this way. This way, this way to ground. All these are not light. Whether I press the lock switch for the door, for the window, for the left, for the right, for the heated seats, I press everything. I don't see any of these lit. What can knock out all of these? If you said a bad ground, you're correct, because this is common to all of them. All of them have to answer to him. They have to come back and current flow back to him. Also, this one over here, this brown wire, if this one opened up, we opened it. Guess what? Current cannot flow to any one of these. It knocked all of them out. So if there will be a fuse here, that fuse will knock out all of them. Let's take another one, a relays, which somebody gave many comments on how the relay works. It is a very difficult subject, but let's continue with that one. Okay, before getting to the relay, AC high pressure cutout switch. So one side is an input, the other side is an output, telling the computer AC high pressure cutoff switch. This is in the rest position. This is telling it that it is connected. This point is connected to this point. That's the rest position. Cut out switch. The name alone gives you a hint. If the AC high pressure is too high, let's say it goes more than 450 psi in certain vehicles, when you put Freon refrigerant in their air conditioning system, you can't just put it in and recharge it. You have to measure the high pressure side. Not just the low pressure side which you put in, but also the high pressure side. If you cannot rely always on the cutoff switch to cut it off. If you go too high, you can damage, obviously, the components. That's what it's there for. And with that hint that I just told you, guess what this does? If this pressure is more, let's say, than 450 psi, more than that, guess what he's going to do? He's going to open the circuit. Once he opened the electrical part of it, compressor doesn't work. That's why cut out is a hint to tell you it cuts off. But not in this position. In this position, it'll open it this way. It'll go open. That's that. Now, let's go for another one. What I was talking about before. The tricky one. Before you have here, for the left rear window switch, we're going to go in two positions. When you have a window, you can either go down or up. Right? You can't go sideways. Now, in this picture over here, we always studied relays. We have things missing here, deliberately. We don't have 12 volts written in, but I did put it in. We don't have motors put it in, but I put it in. We don't have a ground, which I put it in. So, which part of this relay do we start with when we make sure that it's activated? Always start with the coil side. Always start with the coil side. You can't start with the load side. Why? Because he has to work first. This is the hint right there. This dotted line means he controls him. He controls him. Without him, there is no him. So therefore, let's start on this way. What are the main functions of this? And this is the foundation for any. It doesn't matter if there's a fuel pump here. It does not matter if there's a starter motor here. It does not matter if there are reverse lights here. It does not matter if there is the brake lights here. A motor, a solenoid, a valve. This operates the same way in every vehicle, regardless of European, Asian, American, domestic, you name it. A relay will always work. If you grasp this theory, you will know all the analyzations of schematics and how to troubleshoot. First thing, like we just said, stress the point. Which works first? This one. This one. Let's start on the green side. We have 12 volts here. Current flows, right? Does voltage flow or does current flow? Current flows. Voltage does not flow. So current goes here. It comes to this point. It says, okay, I can divide. I can take this road or I can take this interstate. Which one should I do first? Well, let's find the common ground. It's going to go here, and there's a resistor in parallel with it. Here it is. It's going to go to this point. It's going to think at this point. Current says, okay, there's a switch here in the middle. I can either go in the down position, or this switch can make me in the up position. Which one do you think will complete this path for this coil? If you said the up position, you're correct. Why? First of all, I drew a ground. I drew a physical ground. Can a computer give a ground? Yes, it can. So the current is flowing here. We activated the switch. Why? Why? Because we want the window to go up. The window right now is in the down position. We want it to go up. It's cold outside. Close the window, the passenger says, right? The driver says, okay, I'll close the window. Okay, I'll close the window. Obviously, if you close the window, you're going in which direction? In the up position. Up position says, okay, current flows through this, through this, through this. What happens to this one? What did we just say in concept? When this has current flowing through it, look at the dotted wire. That means he will go from here to where? To here. Now, which position is he in? He's in the closed position, and what? What's the magic word that you should say? He is connected to the load. That's why this is called the load side. This is called the control side. He controls him. This has more current than this. A smaller current can control a larger current because this motor, wherever it goes to, is going to drain more current. So he's activated. How? By closing the switch in the up position. Close that window, it's cold, right? Goes to ground, fine. Now we have a path for this to go to the motor. What about where the window is in the up position, right? You're the driver and the passenger says, it's hot in this car. Can't you open the window? Can't you, right? Can't pull down the window. It's too hot here, right? What happens? How do you think current's going to flow? Current's going to flow here, through here. Now it comes over here. What do you think it's going to go to? Current is going to flow. It's going to say, I need a switch to be closed. Why? Because otherwise it's open. I can't go anywhere. I'm stuck. You close that position to go down. The window is in the up position. The window has to go down. It's hot in this car, huh? When it goes down, guess where it's going? To ground. What happens? Look at the dotted line. The dotted line tells you what happens. This will be pulled in. Now it's going in this position. What do you think that accomplished? Accomplished a lot. The current goes here, goes to this point and says, now I'm cooking. Now I have a place to go from here to another motor. One motor for the up position, another motor for the down position. Another motor for this position. So therefore, he's in charge of the down position, he's in charge of the up position. But in reality, we use one motor bi-directional for up and down. We don't use two separate ones. We don't use two separate relays. More components, more parts, more costs. So, like I said, if you understand this, and we're not going to troubleshoot because we did it a couple of times. If you understand this, you'll understand everything. Look at this. Does anything change? Which one has to work first? This side or this side? If you said this side, you're correct. Current has to flow from here to here. Then what happens? This one activates this one. And then what happens? Is two connected to one? Only when he's activated. And then what happens? Goes to a motor. See? We just discussed the issue of a motor. And here it is. To a motor for the radiator fan. For the condenser fan. If it's hot, that fan has to pull in the cold air. Right? To cool down the engine. Here's an example of that. So like you said, you understood this one, you'll understand this one. Whether this is a fuel pump, starter motor, lighting system, horns, the concept stays the same. Whether the vehicle is Toyota, BMW, whatever it is, this does not change. It does not change and say, okay, now I'm in domestic, I'm going to change my function. Now I'm in European, I'm going to change. No. You understand this, you'll understand the load side. Please go to my channel, Joe Electronic Schematics for Auto. And please go to my other one I'm trying to get monetized, Automotive Electronic Schematics by Joseph. That I'm trying to get monetized. I need about 600 hours for that one. Please leave any comments. I'm trying to get back to the comments. As you see, I answer the comments. I just don't put a love sign or a heart sign for that saying, I like the comment. You can see that I always go and I make sure to try to answer questions. Anyway, thanks for watching.